Okay, let's dive into this. Have you ever noticed how some words are just symmetrical? You know, words like level, madame, or the classic race car. It's a fun little quirk of language, right? But how would you actually teach a computer to spot one? That's exactly what we're cracking today, the palindrome code. And we're going to explore two really clever ways to solve this classic programming puzzle.
All right, so just take a look at the word on your screen. That's it. Just level. So, what is it about this word that makes it special? I mean, really look at it for a second. Try reading it backward. Go on. See? It's exactly the same. And that special little property is what this is all about.
Bingo! It's a palindrome, and that's the official definition. Any word, phrase, or sequence that reads the same backward as it does forward. You've got madam, race car, and of course our good friend level.
Okay, so we know what a palindrome is, but how do we get a computer, a literal box of electronics, to recognize one? Well, before we write a single line of code, we need a plan, a universal logic, an algorithm. And trust me, the one we're about to look at is genius in its simplicity. To really get this, I want you to use your imagination. Picture a word. Now, imagine pointing at it with both of your index fingers. Your left finger points to the very first letter, and your right finger points to the very last letter. Got it? Here's how this two-finger algorithm works. Step 1, you're pointing at the start and end. Step 2, you ask a simple question. Are these two letters the same? If the answer is yes, you go to step 3, and you move both fingers one step toward the middle. And then you just repeat that. That's step 4. Keep checking and moving inward until your fingers either meet in the middle or cross over each other. Now, what's really interesting about this is that if you get all the way to the end of that process without ever finding a single mismatch, then congratulations, you found a palindrome.
So that logic is simple enough for us humans. But how do we translate that two-finger idea into actual C code? Let's break down our first method for doing this, what we'll call the in-place check.
Okay, here it is. This is what the whole thing looks like in C. Now, don't worry if it just looks like a bunch of symbols right now. We're going to break down the most important parts so you can see exactly how it's doing that two-finger check. First things first, before we can put our right finger on the last letter, we need to know where the last letter even is. That's what this line does. strlen is just a simple function that tells us the length of the string. It's our first absolutely crucial step. Next up, we need an engine to actually move our fingers. This for loop is exactly that. It creates a counter, I, that starts at the very beginning and lets us move our left finger forward, one character at a time. And this is the heart of the whole thing, the magic. This one line of code is the two-finger algorithm. str of I is our left finger, starting from the beginning, and str of length minus I minus 1 is our right finger, starting from the end and moving backward. This if statement is simply asking, are these two characters not the same? So what happens if they're not the same? Well, we immediately raise a flag. You can think of a flag as just a little note to ourselves that says, hey, we found a problem. And then we break out of the loop. There's absolutely no point in continuing, right? If just one pair of letters doesn't match, we know it's not a palindrome. Game over. Okay, so that first method was pretty slick, right? Checking the string against itself. But in coding, there's almost always another way to look at a problem. So let's explore a completely different strategy, the reverse and compare method. So instead of that fancy two-finger dance on the original string, this approach is much more direct. It basically says, you know what? Let's just create a brand new second string that's an exact reversed copy of the first one. And once we have that, we can just compare the original to its mirror image. And here's what that second approach looks like in C. You can see right away that it's got a totally different structure because it's built around that reverse and compare strategy we just talked about. This line right here, this is the factory. This is what builds our new reversed string. The loop reads the original string, str, from back to front, and it copies each character, one by one, into our new string, which we're calling rev. Now, this line might look a little cryptic, but it is so important in C. That little /0 is called a null terminator. You can just think of it like the period at the end of a sentence. It's how we tell the computer, okay, buddy, the string officially ends right here. All right, so we did all the work of building this reversed string. Now comes the easy part. We use C's built-in string compare function, which is short for string compare. It does all the heavy lifting for us.
It looks at our original string and our new reversed one, and if they're a perfect match, it returns a 0. And if we get that 0, we know we have a palindrome.
So we've just walked through two very different ways to solve the exact same problem. And you might be asking yourself, why does that even matter? Well, it matters a lot, because in programming, there's almost never just one right answer. And understanding the different paths you can take is an absolutely crucial skill.
Which of course brings us to the big question. Which of these methods is actually better? And the answer, as it so often is in programming, is, well, it depends on what you mean by better. And this table here illustrates the trade-offs perfectly. The in-place check is kind of like a minimalist. It's super efficient with memory because it doesn't need to create a whole new string. The reverse and compare method, on the other hand, might be a little easier for another person to read and understand, but it uses more memory because it has to create that copy. See? It's all about trade-offs.
So, the crucial point, the real takeaway here, is this. There's almost always more than one way to solve a programming problem. Becoming a great developer isn't just about memorizing one solution, it's about understanding different solutions so you can pick the right tool for the right job, whether you care more about speed, memory, or just how easy the code is to read.
And that leaves us with a final thought to chew on. We use that outside-in algorithm to check for palindromes. But where else could that strategy work? What other big, complicated problems out there could be simplified just by starting at the edges and working your way to the middle? It's a powerful way of thinking that goes way beyond just coding.